5-minute video. Here we're going to be talking about coating additives. So, what are additives? Additives are things that modify the properties of the coating colour. Very often it's the rheology of the coating colour or the water retention of the coating colour. And the main thing to note about additives is we use them in very small quantities. Whereas we're adding 100 parts of pigment, maybe anywhere from 8 to 15 parts of, or 8 to 20 parts of binder, we're only adding maybe 0.1, 0.2, maybe 1 part of additives. So it's very small quantities, but they make the difference between an average coating and a good coating. Polyvinyl alcohol is one of the additives. This is the structure of polyvinyl alcohol. Some people call it PVA, some people call it PVOH. It has extremely good binding power, so it's really good for improving the strength or the surface pick of coatings. It's also used in conjunction with optical brightening agents to boost the power of OBAs. The solutions of polyvinyl alcohol can be quite viscous, so it depends on the degree of hydrolysis and the chain length, how viscous it will be. It's very, very good for water retention, and water retention we'll talk about in a separate video. But water retention is essentially how well the coating holds its water and stops it from leaking into the base sheet. Material very sort of poor man's polyvinyl alcohol is CMC, carboxymethyl cellulose, derived ultimately from things like cotton or trees. You dissolve up the cellulose and then reprecipitate it, and you've got CMC. This is the typical sort of CMC molecule. These are also used to improve water retention. Not as good as polyvinyl alcohol, but a lot cheaper than polyvinyl alcohol. And also like polyvinyl alcohol, it's a carrier for OBAs, so it helps OBAs work more effectively. As we said, it's produced by dissolving and then reprecipitating cellulose, generally from cotton, but can be from wood. Then we've got foam control agents. We've really got antifoams and defoamers. Antifoams prevent the formation of foam. Defoamers kill the foam that's formed. Because the beginning of this process where you're dispersing pigments is very, very high shear, you can incorporate air, and so you can get foaming products, so you need these to really get rid of the foam. And foaming agents, as we've probably learned in another section, another video, these are normally hydrophobic materials, very water repellent materials, things like high molecular weights, alcohols and fatty acids, things like that. Dispersants. In a coating mix, you want to get as high a solids content as possible, because the higher the solids content, the less the water, and therefore the cheaper it is to evaporate it. So dispersants actually act like little lubricants around the pigment particles, so that you can pack more particles into a small space, and rather than catching each other, they will actually glide past each other, so you can increase the number of them in a given volume. There are two types of dispersants. We've got polyphosphates, common name is Calgon, chemical name is sodium hexametaphosphate. These are inorganic materials. They're cheap, but they degrade very easily over time, and that's what this curve is showing here. If you make a coating dispersion, then after days, around about 4 days, the polyphosphate is starting to disperse, and so the coating colour is becoming more viscous. And by the time you get to 8 days, it's way beyond acceptable viscosity. The other type of dispersant is an organic dispersant, again ultimately derived from oil. These are polyacrylate dispersants. Dispex is a very common one that's used. These are expensive, but they're not attacked by water, so they're long lasting. So there you can see we put some Dispex in, and even after 14 days the viscosity of the solution is low, it's not causing any problems. It's not uncommon for people to use a mixture of both. Then we've got insolubilizers. coatings that are going to be printed on by the offset printing process are continually going to be wetted and dried and wetted and dried, wetted and dried. And every time you wet and dry the coating, it will weaken it. So you put materials in to try and keep that coating strong, to stop it being damaged by the water. And these things we call insolubilizers. Different countries use different words. They're also known as cross-linkers. They're also known as hardeners. The first types of materials that we used were things like melamine formaldehyde resins and urea formaldehyde resins. Glyoxal is fantastic with starch, but doesn't work as well with latex-based coatings. The modern type of insolubilizer is based on zirconium. And whereas these first three make the coating water repellent and protect it in that way, zirconium doesn't make it water repellent. Zirconium makes it water resistant. And lubricants. Lubricants are not there for the coating mix itself, they're there for the benefit of the coating once it's been produced. Lubricants are mainly stearates or wax emulsions, and what they will do, as the coating is being metered off with a blade, because you've got this lubricant going under the blade with all the very abrasive pigment particles, it will make coating blades or coating rods last longer. But the real reason for using it is printing plates. When printing plates go on the surface of the paper, there's always a bit of a movement, so there's a bit of abrasion. So the coating will abrade the printing plates slowly. Having these lubricants there will make those printing plates last longer. And then we've got optical brightening agents. There's many different optical brightening agents. There's one. They're generally based on the stilbene molecule. And we know about OBAs, they interact with light. They bring in ultraviolet light and they re-emit it in the blue part of the spectrum. And the human eye confuses blue and white and makes things think they're whiter. As I mentioned previously, OBAs should not be used when you use TiO2 because the TiO2 will grab the ultraviolet light before the OBA gets an opportunity to. And OBAs usually work better if they work in conjunction with what we call a carrier molecule. And carrier molecules are things like CMC and polyvinyl alcohol. So a summary of our additives. They modify coating colour properties, usually the rheology, which is the way in which they deform or flow. They will modify the water retention, they will help to hold water in the coating, stop it leaking into the base sheet, and they will reduce the water sensitivity of coating, so when they go through the offset printing process they're able to resist that weakening effect of continually being wetted and dried. Okay, well thank you for listening to that video, and please feel free to follow us on this social media.